All right, so this is another video for you guys to use to help you guys study or practice. If you were unsure of what I was talking about today, if you weren't listening, or if you were taking the math test, this is going to be how you can graph a function given the roots and the function itself. Okay. So we always want to start off by figuring out what our roots are. So they're given to us, and we want to write down what they are. So our roots, I have a root at x equals 2. It's counted twice, but I don't need to write it twice because we have multiplicity. So we have a root at x equals 2, and we have a root at x equals negative 5. Okay? So I have two roots here, which are both 2, and one at negative 5. Basically what I just said was your multiplicity, so this is multiplicity. I'll write out the whole thing this time. Multiplicity. My multiplicity of 2 is how many times the root shows up. So I have 1, 2. Shows up 2 times, so it has a multiplicity of 2. And then my x at negative 5, my root there, I only have 1. So my multiplicity of this one is 1. Okay? If you go back and watch a video, or if you just Google it, we know that we can use multiplicity to determine whether or not the graph crosses at our root or if it does not. The general rule is that if our multiplicity is even, not the number, but the multiplicity is even, our graph is not going to cross, not cross. And if our multiplicity is odd, not the number, if the multiplicity is odd, then it'll cross. Okay? So now I have roots, multiplicity. The next thing that I need to check for is the LCT. So the LCT is the leading coefficients test. This is the rise to the left, fall to the right, whatever. Your LCT, so you will be able to use your notes for this, but in general, I hope that you're starting to get a hang of which one is which. For my LCT, I care about the leading coefficient and the degree. So my leading coefficient of my polynomial is positive, so I only care about whether the leading coefficient is positive or negative. So I have a positive leading coefficient, so I'm going to write positive. And then I need to figure out whether the degree is odd or even. 3 is my degree, it's the degree of the largest term. So my degree is 3. 3 is an odd number, so I'm going to write positive, odd. And since it's positive and odd, this implies that it's going to fall as it goes to the left, fall to the left, I'm going to write L for left, and rise to the right. Okay? Fall to the left, rise to the right. At this point, we could really draw the graph as well as we need to. If you want, you can add in other points. A common one is the y-intercept. You don't necessarily have to, but sometimes it's useful to get a more accurate sketch. So my y-intercept occurs when x equals 0. When x equals 0, my y is going to be 0, plus 0, minus 0, plus 20. So it's just going to be, when my x is 0, my y equals 20. So the point 0, 20 is my y-intercept. And now I have all the information that I need to graph this equation. And we're going to see if this might work. So I'm going to draw my graph with a functional marker. To draw my graph, here's my axes. The first thing that we want to do always is to find my roots and mark them on the x-axis here. So I have a root at negative 5, a root at negative 5, and I have a root at 2. So you don't have to space them out perfectly as long as you have this and this. These are only 2 marks that you really need. I also know that my y-intercept is at 20, so I'm going to write 20 right there. So I know that I should go through here, here, and here. Okay? So now we're going to start at the farthest left root here. So my farthest left root on my graph happens to be negative 5. Negative 5, I'm going to start off with the leading coefficients test. So I know that it's falling as it goes to the left. So I'm going to let it fall as it goes to the left. It's going to go down here. Now when I look at this, I need to figure out whether it's going to cross here or it's not going to cross. So I'm going to look at my multiplicity. At negative 5, it has a multiplicity of 1, which means it's going to cross. So it's going to cross the x-axis, and then eventually it's going to come back down here, but I know that it has to go through my y-intercept. So I'm just going to say it looks like that. It might not be perfect. And it's going to come back down to 2. So at 2, I need to figure out, does it cross? Does it not cross? I know that at x equals 2, there's a multiplicity of 2 in the root, so it's not going to cross. So it's just going to touch here, it's going to start, and it's going to come right back up. And that makes perfect sense because it's supposed to rise to the right. So I'm just going to go, and here's a perfectly fine graph, a sketch of a graph. It's not a perfect graph, but here's the graph of this function. This is how you would do it. Given roots in the function, you need to be able to tell me what the roots are, so it should be pretty easy. Their multiplicity, whether or not they cross. That's one part. You should be able to tell me, or you should be able to determine the LCT, whether it's positive or negative, odd or even, and tell me what that means for whether it falls or rises as it goes to the left and to the right. And the y-intercept is a bonus point. And if you can do this, this is how you would graph any function. If you had more roots, you would just do it the same way, but you just have a little bit more listed out there. So that is how you graph roots, or how you graph a function given the roots.